Dear students, I am Pradeep Khanna. Currently, I am heading the Department of Mechanical Engineering at NSUT West Campus. In my previous video, I discussed about the introduction, importance, and need of manufacturing processes and the reasons for its inclusion as a UG subject in engineering streams. I also gave a brief overview of the syllabus contents of Manufacturing Processes 1, which is taught in 3rd semester. In this video, I am going to give a brief overview of the course contents of Manufacturing Processes 2, which is taught in 4th semester. But before proceeding on to the Manufacturing Processes 2 course contents, let's have a brief recap of Manufacturing Processes 1 course contents. Our syllabus is divided into 5 units. So in Manufacturing Processes 1, first unit was based on engineering materials. Second unit was based on casting processes. Third unit was based on welding, soldering and brazing. Fourth unit consisted of powder metallurgy. And fifth was on plastic deformation processes and sheet metal operations and bench work and fitting. You can see that material removal was not included as a unit in Manufacturing Processes 1. There is a reason for that. Actually, this is the topic on which the course content of Manufacturing Processes 2 is based. So let's have a look. So this is the course structure for Manufacturing Processes 2. As you can see that material removal processes are divided into 2 major categories. One is conventional, other is non-conventional machining. Conventional machining processes are those where there is a physical contact between the cutting tool and the material to be cut. The relative motion between the two causes the actual cutting. Here one thing is very important, that the cutting tool material must be harder than the material to be cut. On the other hand, non-conventional machining processes are those where the energy is used in its direct form to remove the metal. For this reason, there is no need for the tool and the workpiece and the material to be cut to be in physical contact. Therefore, it is also possible in such processes that a softer tool might be cutting a harder material. So coming on to conventional machining operations, we have lathe operations, the cutting operations which are performed on lathe machines like turning, facing, taper turning, grooving, etc. Then we have milling operations. Milling operations are those which are performed on a milling machine like face milling, end milling, side milling, plane milling and other milling processes. Then we have other machining operations which involve the machining operations which are performed on machines like lathe, planer, boring machines, broaching, etc. Then we have abrasive processes. These are the processes where abrasive particles in the form of a bonded wheel called grinding wheel are used as the cutting tool to remove the materials. Now, as far as non-conventional machining operations are concerned, we have thermal energy based processes where thermal energy, that is heat, is used to remove the material. Example is electric discharge machining. Then we have mechanical energy based processes where mechanical energy is directly used to remove the material. The example is abrasive jet machining. Then we have chemical machining where the metal is chemically eroded by putting it in contact with the suitable chemicals. Example is chemical machining and chemical blanking, chemical milling also. Then we have electrochemical machining where electrochemical reactions are used to remove the material from the metal to be cut. You can say it's the reverse of electroplating processes. So this is typically the course structure for manufacturing processes 2. Let's move on to the unit-wise detail of the course content. Let me tell you, the first unit in this case is metal cutting. First unit is metal cutting. Second unit consists of these operations. Third unit consists of these units. Fourth unit consists of these processes. And one unit is on gear cutting and jigs and fixtures. So let's have a look at the unit-wise details of the course content. So unit 1 is on metal cutting, as I told. Here we shall be discussing about the mechanics of metal cutting, which includes the identification and determination of the various forces which are at play while cutting is going on. Now calculation of these forces is very important from the viewpoint of estimating the power consumed in metal cutting operations, which is very important. In this, there are certain things which help us. For example, merchant force circle diagram is used to establish relationship between the different forces which are at play while we are cutting the metals. Then we will discuss single cutting point tool geometry and the various tool materials which can be used to cut different kind of materials. Then we might be discussing cutting fluids and lubricants and their effect on cutting efficiency and tool life. We will have a discussion on tool life and the parameters which affect the tool life. Then we have unit 2, which is based on machine tools and their and the various operations that can be performed. So here we shall be going through the construction, types, working, and the operations that can be performed on lathe, milling, shaper, and planer machines. We shall be using in milling machine the multiple point cutting tools, and indexing process shall be discussed in milling, which is very useful in cutting gears. Next we have unit 3, which is on grinding and super finishing. So grinding, as I discussed, is a process where abrasive particles in the form of a bonded wheel are used to remove the metal from the surface. This process typically removes very less amount of metal but is capable of giving a very good surface finish. So grinding operations are typically used as final machining processes. So here we shall be studying the different types of grinding machines like cylindrical grinding, surface grinders, centerless grinders, and then terminology of grinding wheel, its complete specification, which will help us to select a correct grinding wheel for a given application. Then there are other allied super finishing operations like polishing, buffing, lapping, and honing. Unit 4 is based on gear cutting. So we shall be discussing the types of gears and the terminology associated with it. We shall be studying the various operations which are used to cut gears, like gear shaping, gear honing, gear broaching, gear milling, and finally gear inspection also. Then we have jigs and fixtures. Jigs and fixtures are the means which are used to locate and position the job correctly on the machine and clamp it and then guide the tool correctly so that we get the desired operation done in an accurate way. So we shall be discussing the types of jigs and fixtures, the difference between jigs and fixtures and their applications. Then we have unit 5. Unit 5 as I told, is based on non-traditional or non-conventional machining operations. So we shall be discussing about their need, why they are needed when we have conventional machining processes in place. So need and their importance, then their classification, principle of working of different non-conventional machining operations like electrochemical machining, abrasive jet machining, ultrasonic machining, electro discharge machining. These processes shall be discussed in details along with their applications and importances. Once the syllabus is successfully completed, the expected learning outcomes are these. The students come to know about the mechanics of metal cutting, factors affecting the cutting operations and the tool life. Secondly, the student learn about the various conventional and non-conventional machining operations available. Third, for a given product, the student should be able to identify the kind of cutting process used to make that product. Fourthly, the students can select appropriate machining operations, tools, tool materials and cutting conditions to make the desired product at low cost. See, selection of cutting conditions is very important as it affects the final product that we are going to get, the power consumed and the effect on tool life. Then finally, the students attain the necessary skill to machine products or components for their research or their final year BTech projects by utilizing the skills that they have attained while working in their practical workshops. So these are the learning outcomes. These are suggested readings. So we have 5 books here. All of them are good, can be referred to. These 2 books are for manufacturing processes 2 only, whereas the remaining 3 cover manufacturing processes 1 and manufacturing processes 2. If you look at the list of practicals, they have been designed in a way that once you work on the machines, you get sufficient skill to make the products, the simple products on your own once you complete all these practicals. So if you look at the list of practicals, the first 5 practicals are based on lathe machine. First 5 practicals are based on lathe machine. Lathe machine is a very, very versatile and very useful machine tool which is used to manufacture products by removing material. So first is understanding the construction and working of the lathe machine, that is the introductory practical. The second is centering a workpiece on a lathe machine. Then 3, 4 and 5 actually involves real cutting where different operations are performed by the students, and in 5th we teach cutting of threads on a lathe machine. Then 6th, 7th and 8th practicals are related to milling machine. So the students are supposed to make a job on milling machine. 9th and 10th practicals are to be performed on shaping machines where flat surfaces are produced. So in all these 10 practicals, the student learn a lot about the machines, the safety precautions to be taken care of, and working of the machines, and how to make a job in a given time period. So at the end, I hope the information given in this video shall be useful to you to have a good start. With this, thank you and all the best.